uploaded in a while. So I think I'll just do an easy one because I haven't practiced in a while. And the reason for that is because I went to Mexico. And when you go to a third world country such as Mexico, one thing you really should do is to bring probiotics because apparently, so I got food poisoning and probiotics was really able to turn that whole food poisoning around within like a span of 1 to 2 days. And my girlfriend that went with me, she was already taking probiotics like before the trip. And like the same thing that made me suffer a lot basically didn't even touch her. So I feel like probiotics is one of those things where it's like, yeah, I know it's important, gut health, blah, blah, blah. But in actuality, you don't really feel the effects of probiotics until you're like fairly sick with your gut, and then you feel its effects. And it's very easy to think that probiotics are not that effective during your regular day-to-day, and perhaps that's a sure sign that it's working is like if you're not just getting sick left and right, that probiotics are working. I have a link below in the description if you want to use the one that I use to turn my food poisoning around pretty quickly, or you can shop for your own, whatever. And the reason why I'm talking about probiotics before I start this practice is because all of us wants to nail these leetcode or hardware programming stuff so we can get a job, right? And we want to get a job because obviously we just want the money, right? It's not like any of us actually likes doing this stuff. I mean, if we like this technology stuff, we would just start our own company and solve the problems that are a right fit to us, right? There's none of us really want to solve other people's problems. It's unnatural, right? So we're doing this for the money. And what is even more important than money is your health, right? Because imagine getting this job, drinking hot chocolate. Imagine getting this job and getting all the money you want, but then you don't have the health to enjoy your money, then what is the point? Anyway, I'm going to start this mock assessment now because I ranted on long enough. And given an integer n, return true if it's a power of 2, otherwise return false. Can you solve it without loops or recursion? Okay. 2. So one thing I still want to drill on is not typing that fast and really editing my code, because I feel like that's what I struggle with when the code's very long. What about negative numbers? So this can be -2 or 2 to the so there's 2 bases, so there's going to be 2 and -2, and basically my plan is to just run through for p for power in range of 32, so 0 to 31, and then I'll just say 2 to the p, if it equals to n, or let's make this a little bit easier to debug. So if 2 to the p is equals n, so let's say n was 1, p is 0, then that would be true, or -2, p is n. go ahead and return true, return false. All right, so just wanting to drill the whole editing and looking at my code again. So for P in range 32 means 0 to 31. And then I'm going to check both the to and actually like is -8. No, -8 is not a power of 2, it's a power of -2. So actually this kind of threw me off a little bit. That's fine. So if n is 1, then we would just return true because 2 to the 0 is 1, and then 16 to the 4 when you get there is 1, and then we would just basically go here. And I guess you can't really have a power that would, you know, turn this into a negative number. So I guess if n is negative, we just cut it. Now follow up, would you do it without loop recursion? I don't think I want to do that because it's not interesting. Like your loop is only 32 wide, so why would you need to optimize that anymore, you know? I would say an observation I would make is that the binary representation for something that's a power 2 is that it only has 1 1 and all zeros. So perhaps you can left shift or right shift it and then XOR it and then see if it equals to some relation, like a gray code situation. And then maybe that'll like do something. So like for example, you could say like some number and you know, XOR with the number, like is that equal to you know, number plus number, something like that. It's probably, this is probably not true because you could just have this and this would still be true for that. But I guess point being, you probably could figure out some weird relation where you can just have some unique property around like it having a single one. But it's not that interesting to me from a computer science standpoint. So let me just run the code. And then let's try to submit. Okay. All right. So, O of n runtime, I'd imagine like O of n runtime is like you would just sweep all of these once, and then you would just swap it. So for example, this is 4. So 4 minus 1 is index 3 because this is 1 through n. So 4 you'd swap with 7, 7's here, and then 7 you'd find that should be going index 6, and then this would be 3. 3 would swap with blah, 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 blah. 2 would swap with 3, whatever. And then if you already have, so the thing is that's difficult is when you stop swapping, let's say there's a 3 here and there's also a 3 here, then that loop that I just described would just keep swapping 3 with 3 over and over again. So you'd probably just say stop swapping if the destination already has the correct number, and then you move on next one. And that's O of n runtime because you can only swap the number of times however many elements is in your nums array. And then you would just sweep through. And once you sweep through, eventually in this array, you'd end up with like 1, 2, 3, 4. This would probably be like 3 or some extra number. And 8, 1, 2, 3, or 5. There's no 5 either. Anyway, I guess what I'm trying to say is because you already know of this property, instead of doing a sort, you can just do swaps. And then your swaps would allow you to basically have, in this case, 1, 2, 3, 4, blah, 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 blah. And then for each of the elements, then you just check like, for I in range of length of num, if the ith index does not equal 2, so if nums I, so let's say nums 0, I being 0, if that does not equal to I plus 1, then you would just append the missing numbers. Right? So that is an approach. I'm wondering if there's a simpler approach, like you just sort it. But the thing with sorting it is, let's say you have many multiples of 3s, so like 1, 2, 3, 3. Then, then it's a little bit more bookkeeping. I guess you could sort it and then uniquify the, I guess you can just do like a set. I guess that's the simplest way, and probably the way I would implement it, is convert the nums into a set, convert it back to a list, sort it, and I would also keep track of the original n, and then I would just find all the missing numbers by iterating through 1 through n, and just say, hey, if I and n, then yeah. The reason why I don't want to deal with the swapping is because the case where you have to check the destination, I don't really feel like doing that as my first video back. So original length is gonna be the length of nums. In fact, let's just call this n, right? So yeah, and then let's do the set of nums just to uniquify the nums array, and then I will also turn it back to a list so I can work with it pretty easily. And instead of sorting it, I'm not even gonna sort it because I'm not even gonna sort it because like if I sort it, then it's like kind of annoying, like because then you have to keep track of pointers and stuff, right? And I guess what I'm trying to practice is code that is not perhaps the most optimal, but code that I can easily debug. So this will return a unique thing of nums, and then so for I in range n plus 1 to n plus 1, meaning if this was, let's say, 8, this would go from 1 through exclusive 9, so 1 through 8 inclusive, right, which is what we want. If I not in unique nums, go ahead and append I. And then once we're all done, return the answer. I'm very tempted to just run the code and submit it, but let's just maybe run through this 1, 1. 1, 1 should have n equals 2, and list of set of nums would just give me 1. And then so 1 comma 3, which is 1 to 2 inclusive. If I 1 is not in unique nums, it will be for 1, so it's not going to append anything, and then it will check 2, and it will append 2. And likewise here, it would just loop 1 through n and get that. Okay, so this is as expected. Let's see if we run out of algorithmic time. All right, so I guess I don't really have a choice, and I have to do it the original way that I proposed, which, hold on a second. Mm-hmm. 1.15. What's the floor? 0.296. Okay, that's not a lot. Anyway, yeah, maybe I can just do the way that I proposed earlier then. So then so if nums I is already equals to I plus 1, then continue and do nothing, right? So then we only care if it is not equals, and if it's not equals, and the other thing we need to check on is if I plus 1 so let's say this I was 2, right? Then 0, 1, 2, then we're trying to place a 3 here. So if it's not a 3 and nums of I, so the thing that's on the third index must also be within range. Otherwise, if it's out of range, then we don't really know where to place this. So if this is like this and this is like this, so basically this is a bound check, and this is just basically saying it's this place, then what we want to do is actually to swap swap nums I with So let's say this was on let's say on index. This is a 7. So I want to swap this from, which is this second index, with the 6. No, 7 would go where? 7 would go to I equals 8. So in this case, we would swap index 2 with 7 plus 1, or index 8. No. Or is it? 7 wants to go to index 6, right? 1 wants to go to index 0, so 7 wants to go to index 6. So then is this guy correct? Also nums So suppose this n was 4 and nums of 2 is 4. Then I want to place this at the last one. So nums of 2 is 4, 4 minus 1 is 3, and we want to swap 2 and 3. Okay. Provided that the destination isn't already the same number as me. So this prevents, hopefully, the infinite loop. But then this swap, we want to keep swapping actually. So this should be a while. So while this particular index is misplaced, I want to do this probably. So this will prevent an infinite loop. So I want to check it outside here instead of inside here, because I want to, so basically the loop says, as long as these both conditions are true, I want to keep swapping. But if during my swaps I realize that I'm just going to swap infinitely, then go ahead and break it. If I ever detect a number that's outside the range of this, for example, I would just break. And if I actually got the correct number, I would also break. So like, for example, this one I would just break. And this one I would say that, well, I want to swap with this one, except it's the same. So I would just break. And then here I would swap 4 to 7. 7 would go here, and then 3 would go here. 3 would be swapped to here. Sorry, here. And then 2 would go here. And basically your worst case scenario is that you swap everything and everything's sort of in the right place. Or you swap everything and you, let's say this was a 9 and you run into a 9, it goes here and then you're done. Or everything's within this 1 to 8 range, but with some repeated numbers. But if you have some repeated numbers, then what that means is that you're eventually going to run to this case where your from index and your to index are going to be equal, and then you're going to break out of it anyway. So because we're doing a check here, this one can just be a temp thing, so just a regular swap. So temp can just be r of to index, and then r of to index equals r of from index. And then since r from index can be equal to temp. This is overwritten, that's why we have to back it up. And the r from index, we'll just get the swap. So this should have done everything in place and swapped it. And now if we swap it, then yeah, let's just do for I in range length of nums again. And if nums I is not equal to I plus 1, so let's say so if I equals 0 and it's not 1, then we can say our answer dot append this I plus 1, right? And then we're kind of leaning on this logic to be correct. So let me double check again just to flex those muscles of editing and double checking. So if let's say nums of 2, so the third index is not 3, and let's say this one is actually within range, then I want to do this swap of these two indices. So probably from index and to index. And that'll make it easier to debug. From index is basically where I am currently, so that makes sense. My to index is like whatever this value is, minus 1, because the value is 1 index based and the index is 0 index based. And if we detect a cycle, then go ahead and break out of this loop and we won't do the swap, and we'll move on to the next element. So in this case, I'm kind of curious, but I'm also trying to make myself not print stuff. So let's just do it the hard way. So this one will be basically so this one will go here, and then 7, and then 7 will go here, which means 3 will go here, and then 3 will go here, which means 2 will go here, and then 3 will go here, which means 2 will go here, and then this one will detect that it's a cycle because my Q index is going to be 2, and it's it's the same. So now I'll go here, it'll find that 1 is already equals 1 plus 1, which is 2. This one will skip, this one will skip, this one then will be swapped with this, and this one will be swapped with 3, and then I'm just gonna do it here, and then 3 is already placed, so it'll hit this again and break, and then move on to the next guy. This one will also move on and break, and then we get 7, 8. Now in the second loop, we're gonna say for I in range this, if this is not equal 1, then append it, not 2, not 3, not 4. This one will say, well, 0, 1, 2, 3, 4. Nums of 4 is not equal to 5, so that's a missing piece. 6 is also a missing piece, but 7 and 8 are not. So let's run it. I think that's like pretty sufficient. Sufficient run through of the logic and all the indexing. But it fails. Okay. Oh, I do need to return the answer. All right. So other than that missing variable, I was able to solve this question. Fortunately, the somewhat brute force method didn't work. But yeah, I guess going forward, I'm just trying to practice just being very anal about every single line and then rechecking every single line and making sure that the logic is correct. In this case, I did miss the end. Might not seem like a big deal, but ideally, I don't miss that. Yeah. In the future, I'm wondering what ways, maybe for everything I check, I make sure like it exists somewhere, like every variable I check. Yeah. Okay, anyway, that's this one. I hope this helps, and I hope you take your probiotics. Thanks. Finish session. Okay. Actually, yeah, I guess they're both easy, but let's see if what percent the 30 minutes gives us. Come on. So quite the median score. All right.